and welcome to Technical Utkranti. And today we are into part 14 of the C programming series, where we look into the string utility functions, some of them, and basic search and sort algorithm implementation. So let's get started. Let's say in the previous video, we looked into pointers use cases like accessing caller function variables, casting of pointers, and how array and pointers are related. We also saw different types of segmentation failures, and I highly suggest to check out part 13 of the C programming series. In this video, we'll quickly touch upon some string utility functions and then we'll see the implementation of linear search and insertion sort, which are basically simplest search and sort algorithm. So let's get started. Let's see some string utility function. So we'll jump on to our IDE, including this library so that we are able to print whatever we want to print. And okay, so I'll create two strings here. So string is nothing but the array of characters, and I have technical Utkranti, and then Utkranti tech. Okay, I have two strings here. uh, First of all, we'll see how do they look. See, see. So I'm able to print them. Now I want to print their length. So there is one string utility function called strLength which helps us do that. So printf the length of string s1 is %d and new line str length is 1, and similarly for s2. Let's see what do we get. Warning, implicit declaration of okay. So here I have to include this string std string standard library, which provides me these particular functions, right? So this I had forgotten, that's why this error is coming. Now it should get resolved. Again some error. What is the error? Include string dot h. Sorry, it's not std but string. Yeah. Yes. So yeah, we are done. We've got the length of a string. Now we'll compare these two strings. So I'll remove this and let's compare. Okay. So strcmp is the function which compares the two strings, and we'll see how does it work. So f comparison result of s1 and s2 is the cmp s1 comma s2. Okay, so what strcmp does is it compares s characters of s1 with s2, and it compares their ASCII values. So s1 minus s2 basically it will do, and so if you can see like pqrstu, so t comes before u, so t minus u will be a negative number. So this should give us -1. Let us see. Yes, it has given us -1. But if we do s2 s1, it will give us a +1. Yes. And if we compare the two same strings, then it will give us 0. Yes. So this is about strcmp. Now let's do it like there is one more uh, variation to it, which is strncmp, which will compare the first and characters. So let's say I just wanted to compare the first two characters of s1 with s2. Let's see what we get. I think we'll get the same result, I mean, which is not equal. And now if I make the first two characters as same for S2, I make ST Tekranti technical, then I should get 0. Yes. So I hope strcmp and strncmp is also clear to you. Now strcat. So what strcat does is it will append S1 to S2. So strcat and S1 to S2. Let's see what we get. So we get technical Utkranti, Tekranti, technical. Okay. And if we do str ncat, it will append to S1 the first n characters of S2. So let's say I just do this, and as you can see, just te is appended to this. Fine. Now let's see str's copying S2 to S1. So str cpy. Okay. ठीक है. So S1 was technical Utkranti, S2 was Tekranti technical, but S2 got copied to S1 and S1 was printed. S1 was returned from this function and we get this thing. Now let's suppose I do S2 comma S1, then we should get technical Utkranti. I hope. Yeah. So that was strcpy. Similarly, there is strncpy, uh, which I'll not do, and then strchr. So strchr give will search the character. So what it will do is we'll initialize a character, let's say C, and we one second, not character C is equal to C, should work. And strchr in S1 comma C. So it will find character C in S1, and if found it will return the pointer to the character. Okay, let's see if we get this. I think this should be percent %C. Okay, one second. Yes, so it returned the pointer, so I had to dereference it to get the value. So I was searching C, so I got C. Let's suppose I search U, capital U. So I should get that also. Okay. And if I search, let's say Z, then it will return the null pointer. And if we try to dereference the null pointer, it will be a segmentation failure as seen in the previous video. Let's try that also. So see, this is a segmentation failure we are facing. In case where a particular function can return a null pointer in a certain condition, then we should have the if else based mechanism where if the return pointer is null, then we don't dereference it. Anyways, so these were the string utility functions, and yeah, now we can move on to a bit more interesting topic, which is linear search and insertion sort. So we are at the juncture where we'll shift our discussion from pointers to searching and sorting algorithms. Anyways, the purpose is to show the implementation of the simplest search and sort algorithms with array and pointers. So it will enable us to go through this transition of array pointers learning to searching sorting based algorithms. I hope you got the point. So let's start with linear search. Now I create one integer array of, let's say, 4, 3, 6, 1, anything. Okay. Okay. Now search element, let's say I want to search 3, and I also need to have the length of array. So I'll define a preprocessor macro for that. Array length of array, whenever it comes in code, replace it with size of array divided by size of ARR of 0. So this will basically calculate the length of the array, and that's what we are going to do. Int ARRlen equal to array len of ARR. So we are kind of done with having the necessary data, and here I'll write the function. So I would return 1 if I found the element, and 0 if I did not find the element. So its return type is int. Okay, so I have created two pointers. This will be pointing to the end of the array, and this is pointing to this. This is just an array declaration. It's not pointing to anywhere else. So that initialization I'll do in for loop. So start of the array is less than end of the array. So this end and PARR plus plus. Okay, so just a quick reminder that whatever is the type of the array, single increment of it would mean that it has to traverse 1 into the size of the data type of the array. And for all the iterations, if it could not find the element, then the return statement won't get executed and we will return 0. If search element is equal to 1, put as found, else put as not. I hope we are done with the implementation. Let's have a look. So we found the element. Let's write 5 and see if we can find it. Okay, 5 also we found. So guys, I have done this huge mistake here. Instead of comparison operator, I have done assignment operator. So in the second iteration, it automatically becomes equal to this. So yeah, now it should work. not found. So we can try with more numbers. So instead of 5, we'll take 55, and let's take 1. Yeah. So this seems to be working fine. Let's do the sorting algorithm now. So I'll just copy paste the code for array, and in that only we'll make modifications to make it a little quick. Okay, so I have this array and I don't want search element, I want shift element, but before that I need the array length. Int array length is equals to array length, the preprocessor macro that I've created, and I'll pass on my array to it. So I have array length. After having array length, I'll traverse. Note that this traversal could also be performed via pointers that we did in the linear search. So in descending order arrangement, every previous element is bigger than the current element, right? So we'll start with 1 because we'll be comparing the current with the previous one. So if the current element is bigger than the previous one, that's when the problem will come, and we'll call shift element. We'll call shift element. Remove all this. Okay, so we'll have one. This will indicate the value which is supposed to be shifted at the correct place. So I will start like this. So in for loop, the initialization statement executes just once. So if you just want to do some initialization, you can do very well in the first statement of the for loop syntax. Till when do I want shifting? I want shifting till the previous element is smaller than this, right? So if the previous element is smaller than the value that is value that we have got from the main loop, then I want that the smaller element should go towards the right. So that's what we are implementing in the iteration, and this condition will help the loop go on till on the left hand side you find a smaller element, right? This is that big guy which we have to move towards the left. Okay, creating a vacant place on the left. We'll keep on creating with this operation. We'll keep on creating a kind of vacant place on the left hand side of the array, and the condition where this particular thing violates is where we'll insert our element I value. Array of I is equal to I value, and we'll implement one more check over here, which is logical ANDing with I. Why I did that is uh, this I minus minus can go on infinitely at I equal to 0. Even if this condition is not violating, this condition will violate, and we have to stop this thing and place the element at the 0th position. It will work now. I'll just print the array. So for I is equal to 0, I is less than I plus plus, print f percent D error of I before and after, and a line separating the two. Hope it works. Let's see. So we have arranged it in descending order. Yeah. So here we have finished the implementation of the sorting based algorithm as well. So nothing complicated here, just simple linear searching using arrays and pointers, and similarly insertion based sorting implementation. So that's it for today. In the next video, we'll have a look at a bit more enhanced and sophisticated algorithms for searching and sorting.